All right, first and third hour, thank you for being willing to experiment and welcome to our first attempt at switching it up and watching our lecture or our lesson at home and then doing the homework problems in class. Before we get too far into our very first lesson, I just want to tell you a couple different things. I'm going to upload each one of our examples as its own file. So you'll see on your note sheet that you have examples 1, 2, and 3 for this first lesson. Each one of those examples is a part of its own file. You're watching example number 1 right now. The reason I chose to do that is so that way if you want to just figure out one certain little piece, you can go to that exact file or the exact type of problem that you need help on. So I think that's all you need to know for now. Make sure that you know you have a pause button so that anytime I'm talking too fast, you can go back and you can figure out what in the heck I'm saying. Or if you need to rewatch something again, you can watch it as many times over and over and again as you need to. So the start of our lesson, you're going to have to go into your math books and you probably want to hit pause. And I want you to go ahead and define the words or the saying system of linear equations and then the saying solution to a system of linear equations. All right, our first example is called solving systems by graphing. You might remember a couple days ago you were given some different word problems and your job was to solve them using any method that you possibly could. Now what we're trying to do in chapter 7 is we're trying to give you some more, I suppose, more efficient ways to solve those different types of word problems. And the first strategy is, of course, solving them by graphing. So the first two problems that we have up here are just two regular equations in slope-intercept form, and you're used to seeing things just like that. We're going to use the graphing shortcut, and we're going to go ahead and graph the first equation. Our first equation is y equals 2x plus 1. So I'm going to start at our y-intercept of 1, and I'm going to use my slope, and I'm going to go up 2 and to the right 1. I'm going to do it a couple different times so that I can make sure I know exactly where that particular line is going. I'm doing these recordings right now at home, so the lines are not going to be straight, so we're just going to have to kind of deal with it and do the best that we can. All right, there we go. And then our second equation is y equals 3x minus 1, so we're going to start at the y-intercept at negative 1, and we're going to go up 3 and to the right 1, and up 3 and to the right 1, and you might already see something happening. Up 3 and to the right 1. And we could do that again if we wanted to. Let's go down 3 and to the left 1 to make our last point, just so we know where our line goes. And we're going to go ahead and connect those dots. And if you notice, there is a spot right about there where our lines are going to intersect. And that point of intersection is really our solution to the system of equations. So we would have to count over 2 on the x-axis and up 1, 2, 3, 4, 5 on the y-axis. So when your math book asks you for the solution, you would say the solution is 2, 5. And really all we're doing is we're basically figuring out when does one line catch up to the other line, or where do those two lines intersect. Okay, that's all for example number 1. Make sure that you've written down what the solution is on your note sheet. And then you're next going to be working on an example similar to number 1 on your own, so you can go ahead and start that one if you want to before you open the next examples video.